Today's lecture 8 of Basic Electronics is about Opamp Part 8. Welcome to our channel ClassFly community. So today we will deal with the Opamps, one of the application which is integrator. Okay. So see, integrator is a circuit that performs integration of input signals is called the integrator. Basically, what does this Opamp do? This output will give you the integration of this, or it will work as an integrator for this input signal. See, I have represented this input voltage as Vi and the current as the I1, and we know about the virtual ground, right? So if here it is 0, then our Va will also be 0, and we can see a capacitor here, right? And for this, as the current is passing from here, it will go directly to here and not here due to the virtual ground concept. So here I have represent the current flow as IC and the voltage here as VC. Okay, and there will be a V0. This is the voltage output, right? So see, basically what we does, it tells us the output is the integrator of the input signal. So we will apply KCL at node A. That is this one. KCL is what? KCL is voltage by resistance, right? So our I1, this is our I1 and this is the IC. So what I did, I1 will be equal to IC and we will do the voltage difference here. So our VI minus VA it will be. So VI minus VA by R1, this is a KCL, that is the voltage by the resistance, and what will be the IC? It will be VA minus V0, right? But here is no resistance, so VA minus V0 we can't do, but we have a capacitor, so we can do that capacitor with a differentiation capacitor into dVc by dt. We will differentiate with respect to dt. We can do this because we can say that IC is equal to C dVc by dt. Okay. See, Vi is okay, but Va is 0. So I will write this equation like Vi by R1. Okay. Now see, I have to convert this Vc to V0 to find my output, and to solve that output is my output is equal to the integrator of the input. So I have to transfer this VC to V0. So how we will do? I will apply KVL. KVL means whenever it will move from positive to negative, it will be negative, and whenever it will be positive to negative, it will be negative, and whenever it will be negative to positive, it will be positive. See, as the current is moving in this direction, so my capacitor, this side will be positive and this side will be negative. So clearly my VC will be negative. So my VC will be negative, and as my V0 will be then from positive to negative similarly, so it will also be negative. So when I take this V0 to another hand, it becomes V0 minus VC. So that I have only written that V0 is equal to minus VC. Now I will put this part in this one. So what I wrote, minus C dV0 by dt. Now I will integrate both sides, and I will integrate with respect to dt. So my integration lower limit is 0 and upper limit is t. So I did Vi by R1 dt equal to minus C will come out, and integrate from 0 to t dV0 by dt. Okay. 1 by R1 comes out, and 0 to t, that is Vi dt, and minus the V0. We know the integration of dV0 will be V0, right? So it will minus C V0. When I solve it, I get V0 equal to minus R1. Well, I changes the side, so I got minus 1 by R1 C 0 to t Vi dt. So what I got? Output is the integrator of the input voltage. We can simply see this. Now see, whenever, then the waveform will be, if I give waveform is in the square form, and I will get the output waveform as in the triangular form. Okay, but you can also solve it like this. You can solve it by either 2 ways or you can do both in your examination. Now you can solve it by IT is equal to VIT by R. This is the formula, that is V is equal to IR, we know that, right? And VIT is, why I wrote VIT here? Because we know that VI minus VA, that is VA will be 0, so what I will get? VI by R, right? VI by R. So I directly wrote VIT by R. Now see, I can write IT is equal to dQt by dt. Q is the charge. We know the current is respective to charge. So now I can write this QT as dC 0 to minus V0. How? See, this was a circuit, right? This was a VA and this was a V0 and this was a C. So respectively the voltage will be VA minus V0. So I wrote 0 minus V0. Okay. So when I solve this, I get minus C dV0 by dt. Now I will equate this with this one. When I equate this, I get minus C dV0 equal to IT dt. Or I can only write IT dt, not this equation. So see, when I integrate this, I get V0 equal to minus 1 by C 0 to T IT dt. So I can now simply replace this IT dt with this equation, that is VIT. Okay, VIT and R will be here. So this equation is totally similar with the above equation. So you can do any of this equation. So our lecture ends for this application of the integrator. I hope you all understood. Till then, be happy and have a great day.
Now it's the code time. No one is you, and that is your superpower. I hope all of you understood today's lecture, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.